Here's an explanation about automatic transfer switches, grounding, and ground fault protection equipment in electrical systems. We're dealing with a situation involving a 1200 amps, 480/277 volts, 3-phase, 4-wire service needing a 1200 amps ground fault protection equipment main, a 1000 kilovolt ampere, 480/277 volts, 3-phase, 4-wire generator also with 1200 amps ground fault protection equipment, provides backup. A 4-pole automatic transfer switch is considered to avoid nuisance tripping of the ground fault protection equipment. First, let's discuss where to bond the ground and neutral to prevent them from becoming parallel conductors. The key is that the ground and neutral must be bonded at the service entrance. This is typically the location where the utility transformer connects to the 1200 amps service disconnect. In the described setup, the ground and neutral should be bonded at the service entrance and crucially not at the automatic transfer switch. This is because a standard automatic transfer switch is not considered a service entrance device. Bonding at the automatic transfer switch in this situation can create problems. Now, what if the automatic transfer switch was rated for use as service equipment? In that scenario, you could bond the neutral and ground at the automatic transfer switch. However, this requires a specialized type of automatic transfer switch specifically designed to handle the neutral current. Standard automatic transfer switches are not built to manage neutral current and can overheat, leading to failure if used incorrectly in this type of configuration. Are there service-rated automatic transfer switches available with a ground fault protection equipment main? Yes, there are. These types of automatic transfer switches provide an integrated solution for both switching between power sources and ground fault protection at the service entrance. However, they generally come at a high cost compared to standard automatic transfer switches. Finally, let's consider the ideal setup for a 3-pole automatic transfer switch. In this configuration, the 3-phase conductors from both the utility and the generator connect to the automatic transfer switch. Importantly, the neutral conductors from the utility and the generator are then connected to a separate neutral bar. This neutral bar is not directly connected to the automatic transfer switch itself. Similarly, the ground conductors from both the utility and the generator are connected to a separate ground bar, also isolated from the automatic transfer switch. As a recommendation, the best solution is to use a service-rated automatic transfer switch with a ground fault protection equipment main when possible. This provides the most comprehensive protection and reliability, combining the switching and protection functions in a properly designed and rated piece of equipment.